So, again, proved correctly, and then here we would do the same thing. We would start with our okay. So here I'm going to solve and replace cos squared A with 1 minus sine squared A. Gathering our like terms, we have a negative sine squared A minus a negative sine squared A, 1 minus 2 sine squared A. So we have 4 more identities that we don't have to memorize, although we should recognize that there's something useful here. And maybe I can replace. Maybe I can go or replace stuff. I tend to blow things up a little bit more when I'm using double angle identities when I'm proving, just because I want to get everything into a single sine or cosine value, sine, cosine, or tangent value. So those are the proofs. Probably won't be asked to do proofs again of those until you get to calculus. We can, much like we did before, use these for other proofs. What is sine x, or sine 6x equal to? Using 3x. So basically, sine 6x can be written as 2 times 3x. It can also be written as 3x plus 3x, and we could use the sum identity, but since we have the double angle identity, now sine of 2a sine of 2a is here, 2 sine a cos a, or 2 cos a sine a as it's written, but I say it the other way. In this case, my angle is 3x. So this would be 2 times sine of 3x cosine of 3x. So I'm replacing the a in this identity here, sorry, this identity there, my fault, with 3x, because, right, so what we have here is this statement that sine of 6x could be written as 2 sine 3x cos 3x. Or flip it, doesn't really matter. So most often we're going to go backwards. Okay, for example, with the question below. 2 sine 4x cos 4x. Well, 2 times sine of an angle, cosine of an angle. 2 times sine of an angle, cosine of an angle. So this can be reduced to 2 sine, or sine of 2 times that angle. So our angle is our 4x. This is equal to sine of 2 times the angle. So I'm replacing a with 4x, so this becomes sine of 2. Sine of 8x. Now, we're also going to do this with numbers too, but that's simplifying. Now I've got cos squared of an angle. Our angle is 1/2 a, minus sine squared of an angle. Cos squared of an angle minus sine squared of an angle. Well, that's equal to cosine of 2 times that angle. And you can definitely see where this one's going to be useful. This becomes cosine of a. taking a 2-term and writing it into 1-term, which just has the normal angle. So in this case, again, I'm using the angle. What I circled was the angle. I use A in my formula sheets. I don't have to. A lot of places use X. A lot of places use theta. Now this one here, sine of an angle times cos of an angle. Well, we have 2 times sine of an angle, cosine of an angle, but we don't have one that's just 1. Okay. We don't have one that just can be replaced right away. So we're going to do a little bit of math trickery. This, I'm going to multiply this guy by 1/2 and by 2. What have I essentially done? I multiplied it by 1. And why did I do that? Now, we have an identity for 2 times sine of an angle, cos of an angle. So I'll keep that 1/2. Sine of an 2 times sine of an angle, cos of an angle is sine of 2 times your angle. So you see how that worked out? I had to manipulate a little bit to get it to work. 1/2 sine of 5x. I did not have an actual identity that was just sine of an angle, cos of an angle. Putting a 2 there, and then multiplying that entire thing by 1/2 did not change the expression. It allowed me to substitute in my identity. Okay, so we want to simplify this to one of the 3 trigonometric ratios. Now, I know I've said this enough and you're probably starting to disbelieve me because I am going to blow stuff up in this case. I'm going to blow that top guy up for now. Okay? This 1 is annoying me over here. And I have 3 possible identities for cosine of 2x. I could plug in cos squared A minus sine squared A, but then I would be left with 1 plus or 1 minus cos squared A minus sine squared A. I went from 2 terms to 3 terms. That's annoying. Possible. I could plug in 2 cosine squared A minus 1. Don't write this down because it's wrong. Now what happens here? 1 minus negative 1. Now I have 2. So that would reduce down to 2 minus 2 cos squared A. It didn't work. I want to get rid of that 1. Now, you could have done that, and that does lead you down a pathway that works. The other one really doesn't. The cos squared A minus sine squared A doesn't really lead you a pathway that works. But if I replace that, see what happens. The 1 minus the 1, that disappears. Okay? And then we're going to be left with a positive. On the top, we're going to be left, just leave a space, I'm going to work at the bottom in a minute. 0 sine squared x minus a negative 2 sine squared x gives me my positive sine squared a. Or I'll put an x in there and save the same values. So I turn the top term into just one term, I don't have the same problem with sine squared a or sine 2x. I only have one identity for sine 2x, and if I want to put him in here, 2 sine squared x cos squared x. So by reducing the top guy to one term, no addition, there's nothing glued to 2 sine squared x. Those two, that 2 and the sine squared x will cross off, leaving you only with 1 over cos squared x, which is secant squared x. Now, had we gone down this road and used the other one, just with sine squared, it does lead us down a pathway that works. Okay, it doesn't seem to be leading me down the right pathway at the moment. Yeah, it's leading me down the wrong pathway. Oh, never mind, because I went the wrong way. Never mind. Okay, sorry. Do this. 1 minus 2 cos squared. When people make silly mistakes like I just did, kind of annoying. Here we have, because we already did that other one. Here we are going to have 2 minus 2 cos squared x. Now, we are not able to cross things off. As Mrs. Lowry states, that guy's glued. They're glued together. Can't cross anything off. Now, what I can do, I can see that I have a common factor of 2 in that top. And we know that this is sine squared. And we're back to where we were a little bit ago. So it is possible to go down with any one of them. It takes a little bit more work. The exact same thing can happen with the cos squared x minus sine squared x identity. It does lead you down the right pathway. It just takes longer to get to there. Okay, now, we're going to, when we ask for non-permissible values here, I don't want to work with sine 2x, okay? Because it introduces a complex, and I'll introduce that to you tomorrow. But what I can see in this step of the reaction, or of the identity, I can't have sine squared x being equal to 0. and I can't have cos squared x being equal to 0. Because they're on the bottom of the fraction. It's harder to do with sine 2x can't equal to 0. Okay? So here, and in most cases, I'm going to ask you to solve for that in that way. Basically take your identity and turn it into something else. So, sine x can't equal to 0, so x cannot equal to 0 and pi. Cosine x cannot equal to 0, x cannot equal to pi over 2, and 3 pi over 2. So here, 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 and here. Whenever I ask you to solve a multiple angle identity, my first choice is to turn it in, use your double angle identities to turn it into something else. X cannot equal to pi over 2 n. And we'll go over some of that solving tomorrow. So we have an identity here. We have cos to the power of 4x minus sine to the power of 4x is equal to cosine 2x. I could use Pythagorean. Okay. But what stands out at me right now is, what do you see here? I see a squared minus something squared minus b squared, or something squared. Can I factor that? It's the only way you could factor two terms. There's no common factor, so that's out. Yes? Difference of squares. This is going to factor out to cos squared x plus sine squared x, and cos squared x minus sine squared x. We have an identity for cos squared x plus sine squared x, that's 1. And here we have cos squared x minus sine squared x. We just found that today. That is one of the identities for cosine 2x. Look for, you have to be able to recognize difference of squares factor. It is the most common type of factoring other than common factors. Now, I'm going to give you a couple minutes to prove tan 2a is equal to this. Start with the idea that tan 2a is a plus a. Start with that identity, or that idea. So, essentially what I'm doing, here's our sum identity for tangent, and instead of a plus b, I'm writing it as tangent a plus a. Every place I see a b in my statement, I'm going to replace it with an a. So I'm not working with this right now, I'm working with that identity I just had on the other page. I have a tan a plus tan a is 2 tangent a over 1 minus tangent squared a. Again, what we were trying to prove. So there's the tangent identity for the tangent identity for a double angle. If you're given, here's an angle, as I'm going to do in a minute. Find an angle, then give me the double for it. Have to do it this way. I'd like you to evaluate these two statements and write them as a number in both cases. And whether it's the other part of it. Kind of losing you get to replace the entire thing with the entire thing and what you're going to you get the place that entire thing and it's 2 times harder. So you're right. That looks an awful lot like that. But what's missing? Hey, if I want to replace this guy, I have to do it. I can't do that. Times by half. That one there because it looks a little bit like so the key is gone. So the key is like I don't want to change it. What's your most complex set? So this guy. And it's not an identity because it's 2 tangent theta over 1 plus tangent theta square theta. So that's not this identity. But we have an identity for 1 plus tangent theta. Or tangent square theta. Okay, well, 2 times 5 is 12. Yeah, 2 over 1 times 5 is 12. When you get that reduces down to what that fraction where what angle you already know. Great question. So good. Well, 2 times 9, 5 is multiply 2 by 5 times. It'd be 2 over 1 times 5 times. And now it becomes 9 to 5 times. You know, down front. I'm going to do it for 5. Yeah, that's fine. It's not sign, square, it's sign, both. Someone put a captain squared in. It's two, but that's not the squares. What we did. You turn tangent. Two tangent into two sides. But it's over. And then you multiply that by your inputs. There's theta. And you got what happens? This one crosses off with that one. So you have that extra square there. It doesn't apply to the imaginary part, it applies to the secant. That's good. It's that comes out of bottom up. You know what again? I'm not ready for that. Yeah. Yeah, again, we can all do it for that. Yeah, that's right. Or the place to get where for that. And this here will be two. You have identity for one plus transfer. So instead of having to add things like that, we simplify that first. Don't put that two on block. We require both the columns with one.
So when I do my thing to just one plus transfer, we can plug that in. We have an identity one plus transfer data something or something like that. This is the end. This is 10 that we didn't do 15 of the week. Is 10 in the week. So you're going to have to do, if you got 10 to the 8, and this got to there, so, I'll represent something in certain things. So I want to look at here. Well, that's S. Where the photon is different. One plus n where data cannot equal 0. And you get this one. And this where data can never equal 0. So we can vary and the square root of that. So we take the square root of this side. Okay, and we take the square root of this side. What happened here? And there you go. Exactly. Don't do it like that. So there are solutions to this equation. So it's just do it in the equation. Correct. So there's no solution, there's no way to make this long that equal to 0. This is always going to be a square number. 1 plus a square number, those are going to be positive. Whatever the way to do it, right? So x cannot equal to power 2. Power 2 on the computer. So I don't know what the computer is. I would do the 2. That's pi. So this way, if you plus side, is negative sine of pi. Exactly. So I'm going to draw a triangle in my second part. But you want to ask And the 2a is equal to tangent to minus 1 over tan squared of the value. And then I will solve the tangents and replace 2 times sine and replace, and then times the value of the square. This is my book. 17 squared is equal to 8 squared plus 1. You write it out. 17 squared minus 8 squared. So C is equal to 50. It's quite nice. So, what is tangent to from that triangle? Now I want to gap. Because I feel we're going to get figured out that. If you want to gap, you have to have the now you can let the fit and really place it. Right here, you have 10 consistent over 8. You don't get to talk about. It's And that's except we can so, what? Can we tell that so there's no value for candidates. 2, and then it says what's higher 10 to 8, and replace the bottom line with negative 15 over 8. This was fine. So you got your 10 now, you have your current value and now tell me for 10. The 10 is negative 15 over 8. You know what you got, if you're not ever going to value much of it. No, I haven't done the, only a special drawing would be like 500 triple like this. I have a value for 10. Okay. So if you take that you can do in the case, maybe it's 15 over.